Double tapping breakers, otherwise known as tandem breakers, is a common practice where two circuit breakers are installed in a single pole panel space. It allows for the addition of another circuit without having to install a new panel. While double tapping breakers can be convenient, there are some potential risks associated with this practice. Overheating can occur, as double tapping breakers can increase the load on the panel bus and neutral bar, leading to overheating. This can compromise the safety and reliability of the electrical system. Loose lugs are also a concern. The additional weight of two breakers can put strain on the lugs that connect them to the bus. Over time, vibrations and thermal expansion can loosen the lugs, increasing the risk of arcing and electrical fires. Code violations may also be present, as double tapping breakers may violate electrical codes in some jurisdictions. For example, the National Electrical Code, or NEC, requires that each circuit be protected by its own overcurrent device. Maintenance challenges may occur as well. Double tapping breakers can make it more difficult to isolate and troubleshoot electrical circuits. If one breaker trips, it can affect the other circuit as well. Given the potential risks, it is generally recommended to avoid double tapping breakers. Instead, it is preferable to firstly install a subpanel. Adding a subpanel provides additional circuit capacity without compromising safety. Secondly, run a new breaker. Installing a new breaker in a separate panel space is a safer and more reliable option. Thirdly, use a load center. A load center is a type of electrical panel that allows for the installation of multiple breakers in a single compact unit. When inspecting a home, it is appropriate to write up double tapping breakers as a potential safety concern. It is important for homeowners to be aware of the risks associated with this practice and to consider alternative options for adding additional circuits. When dealing with electrical systems, safety and code compliance are paramount. Understanding the potential drawbacks of practices like double tapping breakers is crucial for ensuring a safe and reliable electrical installation. Consider the alternatives to double tapping breakers as solutions for expanding circuit capacity. Subpoles offer a dedicated space for additional circuits, preventing overloading of the main panel. Running a new breaker involves installing a separate breaker in the existing panel, ensuring each circuit has its own dedicated protection. Load centers provide a compact solution for installing multiple breakers in a single unit. When assessing an electrical system, it is essential to verify that the wiring and connections are properly sized and installed. Over time, connections can loosen due to vibration or thermal expansion, leading to increased resistance and heat generation. Regular inspections and maintenance can help identify and address these issues before they become hazardous. The electrical codes and standards play a vital role in ensuring the safety of electrical installations. These codes outline the requirements for wiring, overcurrent protection, grounding, and other aspects of electrical systems. Adhering to these codes is essential for preventing electrical hazards such as shocks, fires, and equipment damage. When adding circuits to an existing electrical panel, it is crucial to perform a load calculation to determine the panel's capacity. This calculation takes into account the existing loads on the panel as well as the anticipated loads from the new circuits. If the load calculation exceeds the panel's capacity, it may be necessary to upgrade the panel or install a subpanel to accommodate the additional load. Grounding is another critical aspect of electrical safety. A properly grounded electrical system provides a low impedance path for fault currents to flow back to the source, allowing overcurrent devices to trip and de-energize the circuit. This helps prevent electrical shocks and equipment damage. Arc fault circuit interrupters, or RFCs, are devices that are designed to detect arc faults, which are a common cause of electrical fires. RFCs can detect arc faults that standard circuit breakers may not detect, providing an additional layer of protection against electrical fires. Ground fault circuit interrupters, or GFCIs, are devices that are designed to protect against electrical shock. GFCIs can detect ground faults, which occur when current leaks to ground. When a ground fault is detected, the GFCI quickly trips, interrupting the flow of electricity and preventing electrical shock. Surge protection is another important consideration for electrical systems. Surges can damage sensitive electronic equipment such as computers, televisions, and appliances. Surge protectors can help protect against surges by diverting excess voltage to ground. When working with electrical systems, it is essential to follow safe work practices. This includes de-energizing circuits before working on them, using insulated tools, and wearing appropriate personal protective equipment, or PPE. Electrical work should only be performed by qualified and experienced individuals. If you are not comfortable working with electricity, it is best to hire a licensed electrician to perform the work. Electrical systems can be complex and dangerous, so it is important to take the necessary precautions to ensure your safety and the safety of others. Overcurrent protection is a critical aspect of electrical safety. Overcurrent devices, such as circuit breakers and fuses, are designed to protect electrical circuits from excessive current. When an overcurrent occurs, the overcurrent device trips, interrupting the flow of electricity and preventing damage to the circuit. The size of the overcurrent device must be properly matched to the size of the circuit conductors. Using an overcurrent device that is too large can allow excessive current to flow through the circuit, potentially causing overheating and fires. The National Electrical Code, or NEC, provides guidance on the proper sizing of overcurrent devices. Conductors are the wires that carry electricity in an electrical system. The size of the conductors must be properly matched to the load they will be carrying. Using conductors that are too small can cause overheating and voltage drop. The National Electrical Code, or NEC, provides guidance on the proper sizing of conductors. Wiring methods refer to the way in which conductors are installed in an electrical system. Common wiring methods include conduit, cable, and wireways. Each wiring method has its own set of requirements and limitations. The National Electrical Code, or NEC, provides guidance on the proper installation of wiring methods. Electrical equipment must be properly labeled to indicate its voltage, current, and other important information. Labeling helps ensure that electrical equipment is used safely and correctly. The National Electrical Code, or NEC, requires that electrical equipment be properly labeled. Electrical inspections are an important part of ensuring the safety of electrical systems. Electrical inspectors review electrical installations to verify that they comply with applicable code and standards. Electrical inspections can help identify potential hazards and prevent electrical accidents. Electrical maintenance is essential for keeping electrical systems in good working order. Regular maintenance can help identify and address potential problems before they become serious. Electrical maintenance should be performed by qualified and experienced individuals. Electrical safety is everyone's responsibility. By following safe work practices and taking the necessary precautions, you can help prevent electrical accidents and ensure the safety of yourself and others. Understanding the fundamentals of electrical systems and safety practices is crucial for anyone working with or around electricity. From selecting the right overcurrent protection to ensuring proper grounding, each aspect plays a vital role in preventing electrical hazards. The National Electrical Code, or NEC, serves as a comprehensive guide for safe electrical installations, providing detailed requirements for wiring, equipment, and safety devices. Adhering to the NEC is essential for minimizing the risk of electrical shocks, fires, and equipment damage. Regular inspections and maintenance are also crucial for maintaining the integrity of electrical systems. Identifying and addressing potential problems early can prevent costly repairs and, more importantly, ensure the safety of occupants. When performing electrical work, always prioritize safety by energizing circuits, using insulated tools, and wearing appropriate personal protective equipment. If you are not qualified to perform electrical work, it is best to hire a licensed electrician who has the knowledge and experience to do the job safely and correctly. Remember, electricity is a powerful force that can be dangerous if not handled properly. By understanding the risks and following safe practices, you can help protect yourself and others from electrical hazards. Voltage drop is an important consideration in electrical systems, especially in long circuits. Voltage drop occurs when the voltage at the end of a circuit is lower than the voltage at the source. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. The National Electrical Code, or NEC, provides guidance on the allowable voltage drop in electrical circuits. Harmonics are distortions of the sinusoidal waveform of alternating current, or AC, electricity. Harmonics can be caused by nonlinear loads, such as electronic devices and fluorescent lighting. Harmonics can cause overheating of electrical equipment and interference with other electronic devices. Power factor is a measure of how efficiently electrical power is being used. A power factor of 1 indicates that power is being used most efficiently, while a power factor of less than 1 indicates that power is being wasted. Low power factor can cause increased energy costs and reduced equipment capacity. Transient voltage surge suppressors, or TVSS, are devices that are designed to protect against transient voltage surges, such as those caused by lightning or switching operations. TVSS devices can help prevent damage to sensitive electronic equipment. Electrical bonding is the process of connecting together all metal parts of an electrical system to create a low impedance path for fault currents. Proper bonding helps prevent electrical shocks and equipment damage. Electrical grounding is the process of connecting the electrical system to the earth. Grounding provides a low impedance path for fault currents to flow back to the source, allowing overcurrent devices to trip and energize the circuit. This helps prevent electrical shocks and equipment damage. Electrical safety audits are comprehensive reviews of electrical systems to identify potential hazards and ensure compliance with applicable codes and standards. Electrical safety audits can help prevent electrical accidents and improve the safety of electrical systems. Electrical safety training is essential for anyone working with or around electricity. Electrical safety training provides information on the hazards of electricity and how to work safely around it. Arc flash is a dangerous electrical explosion that can occur when a short circuit occurs in the air. Arc flash can cause severe burns, blindness, and even death. Electrical workers must be properly trained and equipped to protect themselves from arc flash hazards. Lockout/tagout procedures are used to ensure that electrical equipment is de-energized and locked out before work is performed on it. Lockout/tagout procedures help prevent accidental energization of electrical equipment, which can cause serious injury or death. Confined space entry procedures are used to ensure the safety of workers who must enter confined spaces, such as manholes and vaults. Confined spaces can contain hazardous atmospheres that can cause asphyxiation, explosion, or other serious hazards. Electrical safety culture is a workplace environment where safety is a top priority. An electrical safety culture includes policies, procedures, and training programs that promote safe work practices and prevent electrical accidents. Static electricity is an electrical charge that builds up on the surface of an object. Static electricity can cause shocks, sparks, and even explosions in certain environments. Proper grounding and bonding can help prevent the buildup of static electricity. Electromagnetic interference, or EMI, is unwanted electrical energy that can interfere with the operation of electronic devices. EMI can be caused by a variety of sources, such as radio transmitters, electrical equipment, and power lines. Shielding and filtering can help reduce EMI. Electrical codes and standards are constantly evolving to reflect new technologies and safety concerns. It is important to stay up to date on the latest codes and standards to ensure that electrical systems are safe and compliant. Electrical safety organizations such as the National Fire Protection Association, or NFPA, and the Institute of Electrical and Electronics Engineers, or IEE, develop and publish electrical codes and standards. These organizations also provide training and certification programs for electrical workers. Electrical safety is a shared responsibility. By working together, we can create a safer environment for ourselves and others. Remember that understanding the potential hazards associated with double tap-in breakers and implementing safer alternatives is essential for maintaining a safe and reliable electrical system. Whether you're a home inspector, electrician, or homeowner, prioritizing electrical safety can help prevent accidents and protect lives.